In this video, we're going to be going over the properties of acids and bases, and this is our part 11 video inside of chemistry, chapter 2. Specifically inside of this video, we're going to talk mostly about acids, but we're also going to look a little bit on bases too. And here on this picture, you can see that there's a pH scale. So a pH scale can be used to measure how acidic or how basic something is. So we're going to learn more about that in our upcoming videos and also in this video as well. So let's get started with this video. So we're going to start things off with acids. So what are the physical properties of acids? So acids include the sour taste of certain foods and drinks. And an example is a lemon. So when you have a lemon, you can taste the sourness, and that is a physical property of an acid. And some other drinks, for example soda, that also is an acid, and some candies also have the sour taste. So these are just one physical property of an acid. And inside of the industrial use, acids are utilized industrially for removing rust and in the refinement of processing of metals. So here in this picture, you can also see the acids can be used to refine rust and to make it look like metal again. So this is just what the properties of acids are, and now we're going to go over some examples so that we can learn more about it. So the first example is white vinegar, and white vinegar contains acetic acid, which is used for cleaning and also cooking. And the formula for white vinegar or acetic acid is CH3COOH. And here in this picture you can see that white vinegar can be used for experiments, for cooking, for cleaning, and many different other things as well. So this was our first example of white vinegar. And for our second example, we're going to take muriatic acid. And this is another name for a hydrochloric acid, and it's commonly used for cleaning jobs. And the formula for this is HCl for hydrochloric acid. So you can see that from these two examples, acids are usually mostly used in cleaning jobs because they balance out everything else. So that's why acids are actually used inside of cleaning jobs. So that summarizes a little bit about acids. And now for bases. So the physical properties of bases are described as having a bitter taste and also a slippery feel. So a perfect example of this is soap. So soap has a slippery feel, so that's why it is a base. It's a property of a base. And if you talk about foods, so if the food has a bitter taste, then it's also a base. And examples of bases in everyday life, for example, inside of the kitchen, we use baking soda to cook, and we use soap to clean our hands, to wash everything. So these are just some examples of bases. So now looking into actual real examples of bases, we use the oven cleaner. So oven contains of sodium hydroxide, which is a strong base used for grease dissolving properties. So oven cleaners contain of sodium hydroxide, which is a really strong base. And you can also see that bases are also used in cleaning products as well. And the formula for the oven cleaner, which is sodium hydroxide, is NaOH. And now for our second example, as we covered before, we're going to talk about baking soda. So baking soda is used in cleaning and also cooking. So baking soda is sodium bicarbonate, which is a mild base for used in baking and also neutralizing odors. So baking soda is obviously used in baking, we use it all the time, and is also used for neutralizing odors. And the formula for baking soda, which is sodium bicarbonate, is NaHCO3. So now since we looked a little bit on the properties of acids and bases and some examples of them, now we're going to look at defining acids, which is the Arrhenius theory. And we're going to look about bases in our next video, so also stay tuned for that. So inside of this theory, we're first going to talk about the historical context. So inside of 1884, Arrhenius, which was a Swedish chemist, he proposed a theory to describe the behavior of acids and also bases in water. So for conductivity of acids, so right now we're going to talk about acids. So pure water by itself is a molecular compound and it does not conduct electricity. And we covered more about why pure water doesn't conduct electricity in our previous videos. But we know that it isn't because of the molecular compound, it's not as strong. But while acids and bases solutions actually do because they contain ions. So pure water by itself, so what Arrhenius said, when you have pure water by itself, it does not conduct any electricity because it is a molecular compound. But once you add an acid or a base into it, so most of the time when you add an acid, it's always going to contain and conduct electricity because it contains ions, and then it's going to be able to conduct electricity because of that. So this was one thing that Arrhenius said, which was the conductivity. And furthermore, the definition of acids. So according to Arrhenius, acids are substances that release hydrogen ions, which is H+, when dissolved in water. So that's why you're going to always see H+ ions inside of every single chemical formula inside of an acid. And we're going to look more about that in the next slide for some examples. But this was one thing that Arrhenius said on the definition of acids. They always release hydrogen ions when they're dissolved inside of water. So an example that he gave was hydrogen chloride gas, which is HCl in the gas form, and it dissociates into hydrogen plus and also Cl minus ions inside of water, and then that makes it a solution acidic. And basically the formula was HCl in gas form. It turns into two different, so H+, which is the hydrogen ion, and then a chlorine ion of Cl minus. So now moving on, we're going to look at some important acids that's always going to come up. So if you're learning chemistry, if you're just starting, you're always going to see these acids. They're the most common ones. And we're also going to look at his theory and how they apply. So what Arrhenius said was that they always release hydrogen ions. So that's why in acids, you're always going to see hydrogen by itself. So for our first example, we can see that there is sulfuric acid, and the formula is H2SO4. And you can see that hydrogen is there by itself. And for some notes on the formula, they're most widely used in industrial chemicals, and they present in automobile batteries. They have one component of acid precipitation. So these are just some notes on sulfuric acid. This is a really common one. And for our next one, we have hydrochloric acid. And the formula for this is HCl. So you can see that there is another hydrogen ion there. And some notes for it is that it is sold in hardware stores as muriatic acid, and it's used in water treatment and processing of metals. And for our next one, we have nitric acid, which is HNO3. So you can see here that H is again there, further demonstrating Arrhenius' theory. And this nitric acid is used to manufacture fertilizers, explosives, and also dyes. And another thing is it is a component of acid precipitation. And for our next one, we have carbonic acid or carbonic acid. And the formula for this is H2CO3. And it's present in rainwater and also carbonated drinks. And finally, for our last one, we have ethanoic acid, and it's CH3COOH. And this is commonly used in white vinegar, and it's also used in the home commonly as well. So these are 5 really important acids that are always going to be coming up. So to sum up everything in this video, we talked about acid properties, we talked about base properties, and we also looked at some examples of both of them. And then we also talked about the Arrhenius theory on acids. And in our next video, we're going to discuss about the properties of bases and some examples of it. So that summarizes everything for this video. So thank you so much for watching from Try to Be Useful, and we'll see you in our next chemistry video.